All right, these are the answers to lesson 37-1 to check your understanding and the practice. So it says just calculate the surface area. If you have a cube that's 4 feet, so you calculate that using the formula, you get 96 square feet. Now it says predict the surface area if the edge length of the cube is tripled. So what you should do, your scale factor, the scale factor for the edge right here is tripled, so times 3. But the scale factor for the surface area over here, you take this and multiply it times, not times 3, but times 3 squared. And that's how you take this and multiply it times 3 squared, and that's how you get the 864 square feet. By what factor does the surface area increase? By a factor of 9, which is 3 squared, which is the scale factor of the edge length squared. Why? Edge length is in feet, surface area is in feet squared. So you take the scale factor and you square it. Suppose the edge length is quadrupled. Quadrupled means times 4. By what factor will the surface area increase? 16. Why? Because 4 squared is equal to 16. So that's where they got the 16 from. Describe any pattern you notice between the surface area and the scale factor of the edge length. So the scale factor for the edge length is, I don't know, then the scale factor for the surface area will be x squared. Okay, that's the pattern that we've seen. The radius is 9. Find the volume. They did that. Predict the volume if the radius is tripled. So volume. So for volume, we're going to take the scale factor, which is times 3, and we're going to cube it. Why? Volume is inches cubed or units cubed, feet cubed in this case. By what factor? So this is the number that we get. By what factor does the volume increase? Right here, 27. Okay. Suppose the radius is quadrupled. That means times 4. By what factor would the volume increase? Times 4 cubed. So 4 cubed is 64. Describe any pattern you notice between the volume and the scale factor. So if we take the scale factor of the edge length, and let's say that that's x, then this factor, good Lord, the scale factor for the edge length is x, then the scale factor for the volume is going to be x cubed. And that's what they're saying right there. The volume increases by the cube of the scale factor. All right, so let's go down here and get the answers to these. What's the surface area of the new table? Here's the answer, 121.5. Let's see, one of the cubic displays has a side length of 6. Okay, so right there, Howie wants to purchase a new table, but he wants its side to be reduced by 25%. So we would take this right here and we would multiply it. The scale factor is 0.25. So the surface area is going to be times 25 squared, and the volume is going to be times 25 cubed. Now, when I say the volume of the new table, you're going to have to find the surface area and the volume of this one, and then multiply them times this right here. So, number 11, part A, what's the surface area of the new table? That's where that comes from. And B, what's the volume of the new table? And I don't know, what's 6 times 0.25 is 1.5. So 1.5, 1.5, 1.5. And then you could do a quick check to see if we got the surface area right. So 1.5, sorry, my dog's playing with this toy. 1.5 squared will give you the surface area times 6. And that came out to be okay, so 36 is the surface area of each one of these, and there's 6 of them. So 36 times 6. Oh, goodness. Give me 216, but that would be for this one. So if you take 216 and then we multiply it times 6 because there's 6 of them, that gives you 216. Then you take that and multiply it times 0.25 squared. And I'm getting 13.5. So, oh, I know what's happening. I'm taking 25% away. If I take 25% away, then that means 75% is what's staying. So I'm multiplying by the wrong scale factor. That's what I'm doing wrong. So let me see. Yeah, I have to delete everything. So you multiply by 0.75 because it's reduced by 25%, then 75% is staying. Or you could say if you multiply by 0.25, that's what you subtract away. So it's going to be 6 times 0.75 would give you 4.5. So that's the length of the new table, 4.5. There you go. So now the numbers will come out right. That number will come out right. That number will come out right because I've got the new length. Number 12, a sphere with a diameter of 5 feet is being painted. Now that's the diameter, so be careful. How much more paint would be needed to paint a sphere that has 4 times the diameter? So the edge, and I know for a sphere we don't have an edge, but we consider the radius and the diameter to be kind of like our edge. Our edge is increasing by 4 times. What are they asking me for? Where does paint go? We're not filling the sphere with paint. We're putting it around the outside, so that's surface area. So 4 squared, which will give us 16, is 16 times as much paint. Suppose the diameter of the sphere in 12 was tripled. What effect would that have on the volume? If the scale factor for the diameter was tripled, then the scale factor for the volume will be 3 cubed. So it would be 27 times bigger, or 3 cubed. 14. Purchase a refrigerator. The sides of the refrigerator are congruent. The volume is this. The refrigerator in the dorm kitchen is similar shape, but has a volume of that. Write a simplified ratio for the side length. So if we take the volumes, 5.832, that's my dog's playing. And the volume of the other one, 157.464. Now remember, those are volumes, so that is our scale factor cubed. So in order to figure out what our scale factor is, because they're talking about a simplified ratio for the side length, then we have to cube root those. So we have to figure out what that is cube rooted. So 5.832 divided by 157.464, and then take the cube root of that. I did my calculator wrong, so we'll see if I got the right answer. Yeah, I got 1/3. So that equals 1/3. So on my calculator, I typed that in exactly the way it was. And then I put the cube root around it, and that came out to be 1/3. So the ratio is 1:3. Now, if that's the ratio for the side length, what is the ratio for the surface areas? Well, 1/3 squared, because area is squared, will be 1/9. Okay, it says, let's critique the reasoning of others. Buoys are used in the ocean as markers. The spherical shape marker in current use at a beach have a radius of 2 meters. One of the lifeguards stated that the radius of the buoy was doubled, that the buoys would have twice as much surface area. We know that that's not right. If the radius was doubled, so that means the scale factor for the radius was times 2, then the scale factor for the radius was times 2, then that means the scale factor for the surface area will be times 2 squared. And 2 squared will be 4. No, the surface area of the buoy will increase by a factor of 4, not 2. Okay, so that is the end of 37-1. Thank you.